Dual injection versus direct injection. The secret to Toyota's lifespan isn't magic, it's fuel delivery strategy. And most people don't realize how much it affects carbon buildup, oil contamination, and long-term wear. Let's break this down. Most people hear direct injection and think newer tech, more power, more efficiency, so it must be better, right? But here's the pattern interrupt. Direct injection is exactly why a lot of modern engines start running rough, losing efficiency, or needing expensive cleaning long before they should. And Toyota's quiet advantage is that many of their best long-life engines don't rely on direct injection alone. They use dual injection, both port injection and direct injection, so they get the benefits of DI without swallowing all the long-term downsides. If you want to understand cars before you buy them, you're in the right place. Subscribe, because cars aren't complicated, they're just poorly explained. Quick favor, and I'll give you a real reason. Share this with a friend who keeps saying GDI is always better, or who's shopping a used car and doesn't understand why some engines coke up with carbon. This one detail explains why 150,000-mile engine still feels smooth, and another feels tired and expensive. All right, 2 quick facts to lock in before we compare them. Fact number 1. Direct injection improves power and efficiency largely by controlling heat and knock, basically letting an engine run higher compression and smarter timing without detonating itself. Fact number 2, direct injection also removes a free cleaning effect that older engines had because fuel no longer washes over the intake valves, and that's where the carbon problem comes from. Now, I've been around enough engines to tell you the engines that age gracefully usually aren't the ones with the fanciest brochure. They're the ones that stay clean inside and keep stable combustion over time. So what's the difference between these systems in plain English? Direct injection, in simple terms. Direct injection, often called GDI, sprays fuel directly into the combustion chamber at high pressure. Why engineers love it? It cools the air charge inside the cylinder, which helps prevent knock. It allows higher compression ratios and more aggressive timing. It can improve fuel economy and torque, especially at low to mid RPM. It can reduce pumping losses because the engine doesn't always need as much throttle restriction. So on paper, it's a win. But here's what nobody tells you. GDI is also a dirty technology in one specific place, the intake valves. Because in a GDI-only engine, air comes in through the intake ports, but fuel does not. So the back of the intake valves never get that fuel wash cleaning that port-injected engines naturally had. And what's floating through the intake stream? Oil vapor. Where does that oil vapor come from? PCV system vapors, blow-by gases, sometimes a little oil mist from the crankcase ventilation design. And on turbo engines, you can add more heat and more deposits into the mix. Over time, those vapors bake onto the intake valves like a barbecue grill that never gets cleaned. Question: what happens when airflow gets disrupted by deposits? You start getting rough idle, misfires under load, hesitation, worse fuel economy, and in some engines, cold start shudder that feels like the car is aging early. And it's not because the bottom end is worn out, it's because the engine is breathing through a dirty straw. So that's direct injection. Now, dual injection is Toyota's have-your-cake-and-eat-it move. Dual injection, in simple terms, means the engine has port injectors that spray fuel into the intake port, upstream of the intake valve, and direct injectors that spray fuel into the combustion chamber. Toyota often markets versions of this as D4S on many naturally aspirated engines and D4ST on some turbo applications. Names vary by engine family and market, but the concept is the key. Here's why it matters. Port injection's superpower. It washes the intake valves with fuel. That dramatically slows carbon buildup. Direct injection superpower, it improves knock resistance and power efficiency under certain conditions. So a dual injection engine can run port injection when it wants cleanliness and smoothness, and direct injection when it wants performance, efficiency, or emissions control. This is where it gets interesting. The best systems don't choose one. They switch depending on load, RPM, temperature, and driving conditions. So when does an engine use port versus direct? Generally speaking, and it varies by calibration, dual injection engines often do something like this. At low loads and steady cruising, they may lean more on port injection for smooth mixing and clean intake valves. At high load, hard acceleration, or when knock risk is high, they use more direct injection because spraying fuel into the cylinder cools things down and allows more aggressive timing. On cold start, many modern engines use strategies to heat the catalytic converter quickly. Some will use direct injection and timing tricks to warm up emissions equipment faster. Some will blend both. The exact recipe depends on emissions targets and hardware. Under certain particulate emissions concerns, port injection can reduce particulate formation compared to DI-only combustion in many cases, because DI can create richer pockets and more soot-like particulates if not perfectly controlled. And yes, this particulate detail is very current. Globally, emissions regulations have pushed many DI engines towards particulate filters in certain markets. The point is, port injection isn't just old tech, it still solves modern problems. So why does this extend Toyota lifespan specifically? Because Toyota's long life reputation is not only about strong blocks and good machining, it's also about avoiding the failure patterns that take out other brands early. Toyota's quiet advantage: fewer GDI-only aging problems. When you look at a lot of the industry's common modern engine complaints, especially in the used market, many of them cluster around GDI-only side effects. Intake valve carbon buildup. This is the big one. Dual injection directly attacks it by using port fuel wash. Fuel dilution and oil contamination risk. This one's nuanced, so stay with me. Some DI engines, especially with lots of short trips, can end up with more fuel getting into the oil. Not always, not every engine, but it's a known pattern across the industry because DI can have different wall wetting and cold start behavior. Toyota's calibrations tend to be conservative, and dual injection can help reduce how hard the direct injectors need to work in everyday driving. That doesn't mean Toyota oil never dilutes. It means Toyota tends to engineer for predictable ownership, not maximum laboratory numbers.
High-pressure fuel system stress. Direct injection requires a high-pressure fuel pump and high-pressure injectors. DI hardware is expensive. When it fails, it's not a $40 part. It can be a real bill. With dual injection, the engine can rely on port injection in conditions where DI isn't necessary, potentially reducing DI duty cycle over the engine's life. Again, this is not a guarantee. It's a design philosophy. Reduce stress where you can. Now, let's be fair. Dual injection isn't free. The honest downside of dual injection. Dual injection adds parts. You have port injectors and direct injectors. You have more control complexity. You have more potential failure points than a simple port-injected engine. So why would Toyota do it? Because Toyota tends to spend money on systems that reduce long-term warranty and ownership headaches. From an engineering perspective, they're paying for cleaner intake valves over time, more stable combustion as the engine ages, flexibility to meet emissions without pushing one system too hard, and smoother drivability across climates and fuel qualities. Most people miss this part. Toyota isn't chasing peak numbers, they're chasing stable numbers at year 12. Why DI-only engines can still be good and why some are. This is the trust moment. This doesn't mean every DI-only engine is doomed. Modern DI-only engines can manage deposits better with better PCV oil separation, improved valve and port design, better injector targeting and pressure control, and updated software strategies. And many manufacturers now use particulate filters and refined combustion control to address the emissions side. But as a used car buyer, you're not buying the brochure, you're buying the previous owner's habits. Short trips, cheap oil, late oil changes, lots of idling, those behaviors tend to amplify the downsides of DI-only designs. Dual injection makes the engine more tolerant of average ownership. That's the point. Real-world signs. How do you know carbon buildup is becoming a problem? If you're looking at a used GDI-only car or even a dual injection car that's been neglected, watch for these. Cold start roughness that improves after 10 to 30 seconds. Random misfire codes that come and go. A shaky idle at stoplights. Noticeably worse fuel economy than expected. And hesitation when you tip into the throttle lightly. And here's a question that keeps people watching because it matters. How do you prevent it? Prevention without the internet nonsense. Number 1, drive it like an engine sometimes. Engines that only do short trips and never get fully warm build deposits faster. Occasional longer drives at full operating temperature help. Number 2, keep up with oil changes. This matters more on modern engines than people want to admit. Old oil increases vapor contamination and deposit formation. Number 3, don't fall for miracle-in-a-bottle claims. Fuel additives can help keep injectors cleaner, but they won't magically clean intake valves on a GDI-only engine because fuel doesn't touch those valves. If an engine needs valve cleaning, it usually needs a physical cleaning method, like walnut blasting, depending on engine design and severity. Dual injection reduces how often that becomes necessary. It doesn't make maintenance irrelevant. Now here's the myth-busting section. Myth: direct injection is always better because it's newer. Nope, newer just means different trade-offs. Myth: port injection is outdated. Port injection is still used because it solves real problems: valve cleanliness, mixture preparation, and in many cases reduced particulate formation. Myth: Toyota engines last because Toyota is underpowered. Also not the full story. Toyota engines last because Toyota prioritizes thermal control, conservative tuning, robust cooling and lubrication, and designs that tolerate real-world neglect better than average. Dual injection fits that philosophy perfectly. So what's the takeaway if you're buying a car? Buyer advice: what to look for. If you're shopping Toyota, Lexus, or any brand that offers dual injection, that's a green flag for long-term cleanliness and drivability, especially if you plan to keep the car. If you're shopping DI-only engine, don't automatically run away. Just shop smarter. Look for maintenance history. Avoid cars that only did short trips if you can. Pay attention to cold start behavior, and understand you might eventually pay for intake valve cleaning on some models. And here's a practical question. Does this matter if you're leasing? Not as much. If you're leasing or keeping a car 3 years, you'll rarely feel the long-term deposit story. But if you're the person buying at $60K, $80K, $120K, this matters a lot. Because Toyota lifespan isn't just the strength of the metal, it's the cleanliness of the breathing. Let's wrap it up clean. Summary: dual injection versus direct injection in 1 minute. Direct injection: great for power, efficiency, and knock control, but can create long-term intake valve carbon issues in DI-only setups. Expensive high-pressure hardware. Dual injection: uses port injection to keep intake valves cleaner, uses direct injection when it benefits performance, efficiency, or emissions. More complex, but often more tolerant of real-world ownership. So the secret to Toyota's lifespan isn't that they avoided modern technology, it's that they used modern technology in a way that reduces long-term penalties. If you learned something new, subscribe. Next, I'll break down which Toyota engines actually use dual injection, which ones don't, and what that means when you're shopping used. And share this with a friend who thinks GDI is automatically an upgrade, because understanding this one design choice can stop them from buying an engine that feels great at 40,000 miles and annoying at 120,000.